Hello everyone, in this video I'm going to go over the backpack optimization problem and also talk about a couple new skills to make you a little more efficient with your use of spreadsheets. And then also the last type of constraint that we haven't talked about, and that's the bin or the binary constraint, which they abbreviate bin. So first of all, this problem is trying to fill a backpack with items to get the maximum benefit. However, the backpack can only hold a certain amount of weight. Um, and then there's some other rules. We have to make sure that we have something to drink. We have to make sure that we have some source of protein, a first aid kit. So each of these different things has a weight. If it's too heavy, we won't be able to walk very far. So the first thing that we want to do is list all of the things that we're going to think about bringing. So we'll put flashlight here, we'll put cereal here, first aid kit, etc. But I don't really want to type them all, and copy and paste all of those seems a little like doing the most. So I'm going to select all of these, and then I'm going to copy them. And then I'm going to come down here and paste them, but I'm not just going to do a normal paste. I'm going to right click or go up to edit and click choose paste special and then paste transposed. And what transpose does is it takes horizontal things and makes them vertical, or vertical and makes them horizontal. So that'll save us a little bit of time. How many of each thing am I going to bring? I don't know, so I'm going to put in random numbers. It really doesn't matter what numbers you put in. Just like always, the computer is going to change these based on the rules and the objective that I give it. So next is the objective function. That's the benefit of each item. So each of these are rated from 1 to 10, how much benefit I will get from the items. Again, I'm going to take those, I'm going to copy it, and then for my objective function, I'm going to paste special, paste transposed, and it will move them across horizontally. And now if I did bring 1 flashlight, 2 cereals, 3 first aid kits, 4 waters, 3 Gatorades, etc., what would be the sum of the benefit of all those? So I'm going to use my sum product formula we've been using, equals sum product, parenthesis, and then grab the decision values, comma, grab the objective function, parentheses. So I would get a benefit of 137. But could I carry all of that? I don't know. So we're going to put that in the constraints. So the constraints, our first constraint is weight, right? How much do all of these weigh? And so for those, I'm going to grab the weight of each item. Again, I'm going to copy it, and then I'm going to paste special transposed and put them all over here. And then I'll find out how much they all weigh. So equals sum product. The number that I'm bringing, comma, the weight of each item. That would weigh 103 pounds. If you remember, we can't carry 103 pounds worth of stuff. I'm going to make all of these columns a little more narrow to make it easier to see. The limit is that that has to be less than or equal to 26. Right? Less than or equal to 26 pounds was what we said at the beginning. All right, so could I carry all of those things? No, they would weigh 103 pounds. There's no way I want to go backpacking and carry around 103 pounds. I do have some other rules. One of the rules is that we have to bring at least one source of liquid, either water or Gatorade. So I'm going to put that as my next constraint. I need to bring a liquid. Flashlights don't count as liquid, so I'll put a 0. Cereal does not count as liquid, but water counts as something I can drink, so I'll put a 1. 1 water would count as one thing to drink. 1 Gatorade would count as one thing to drink, so I'll put 1s there. I don't like to drink bug spray. I'm umbrellas, knife, cheese, or beef jerky. And I have to have my sum product here. So I'm going to use that shortcut we talked about. Put the $ between the letter and the row number so that if I copy things down, it knows to keep those as an absolute reference up to row 20. And so I can fill that down. If I brought this number of things, I'd have 4 waters, 3 Gatorades. That would add up to 7 liquids. That's going to be greater than or equal to 1 to make sure that I have at least one of those things. The other rule that we had is proteins. I need at least the cheese or the beef jerky. And so that's going to be in row 27. Right. The only things that count as cheese as proteins are cheese and beef jerky. So 1 in both of those. Fill my formula down. Again, that's got to be greater than or equal to 1 to make sure that I have at least one of them. And then the last rule is the first aid kit. And the only thing that counts as a first aid kit is the first aid kit. So I'll put the formula down here. And greater than or equal to 1 for that one as well. So now I can use Solver to try to solve the problem and see how many things I should bring. So I'll go up to my add-ons and open the sidebar. All right, so obviously I did this earlier. All right, so I'm going to go up to add-ons and go to open solver, open sidebar. And now I can solve the problem. So the objective is to maximize how useful my backpack is. So I'll put that here. The objective sense, we want to maximize it. The variable cells, I want the computer to tell me how many of each of these items to bring. So I'll select them and click add. And then the constraints, I've got the 2 different directions for the constraints this time. So I'll add those in 2 different groups. Right? I want my weight, top update, to be less than or equal to the amount that I can carry. I'll save that. And then I also want all of these things, the liquids, protein, and first aid kit, to be greater than or equal to my limits for them, greater than or equal to 1 for each one. Save that constraint, and then I'll solve the model, and we'll find out from the computer how many of each item it thinks that we should bring. All right, so the computer says don't bring beef jerky, but do bring cheese. Don't bring a knife, umbrella, bug spray, Gatorade, but do bring water. Bring a first aid kit. Don't bring any cereal, and bring 7.5 flashlights. Obviously, flashlights are the most useful at 8, the least weight at 2, so we should bring a lot of them. I hope you see the problem with that. First of all, bringing half a flashlight is not very useful at all. But secondly, I could see maybe bringing 2 flashlights, but I think I would probably just stick with 1 so that I had room to bring other things. So we're going to add another constraint to this, and that's to say that everything is either going to be a 0 or a 1. Right? We're only going to bring 1 of something or 0 of something. And so what we're going to do for that is select all of our decision values. We're going to add that as a constraint, and then we're going to click on the type of constraint and go down to bin. Bin stands for binary, which means two choices, 0 or 1 are the only options. So I'll save that. And then I'll run it again, run the solve again, and it will tell me that I should still bring a flashlight, I'm sure, because that's really light and useful. Should still bring a first aid kit. But now I'm going to bring Gatorade instead. I'm going to bring bug spray, an umbrella, and a knife, and no cheese and beef jerky. So my total weight is 26. I have one of each of the items I said I had to have at least one of. My objective function came out to be 47, which isn't a number that really means much, but it just is how useful everything is. And that's the backpack problem.